Hello. Right, threaded inserts, heat inset type inserts to go into plastics to put a thread in them. These I've just done in here. Backstory to this is my big Cossel printer broke a few days ago. It was using a Flex 3 drive extruder, and unfortunately the outer of the both rotary bolt cable drive came detached at the extruder end where it was moving about a lot, and allowed the inner cable to kink, and it then just twisted itself off at the kink. And instead of replacing that, I'm going to try something else. I've seen a lot online about the little orbiter extruders, which are tiny and relatively light, and you can fit these directly on to the smart effector I'm using on the Cossel. But it needs a printed adapter, like that, which this bolts onto, and then that sets off as an angle on the smart effector at that end. So it's got room for the delta rods around it where they spread out without interfering with them. But that's okay to print. Luckily I've still got the old Overlord Pro printer working. But the little brass inserts, 3mm and 2.5mm, are something else. I've never tried those before. I've used riveting ones for years. They use them in something like a pop rivet gun that's got a threaded tip rather than a hole, and expand into metal, but I've never used these heat insert ones. And I've just been a bit of studying online, and apparently the best way of fitting these is with a special adapter tool, like a soldering iron tip that's just a plain piece of brass with a pin that fits down the centre. And everything I've seen online says basically if you try and do them just with a soldering iron, by either putting the soldering iron bit straight down the centre or pressing across the things, it's likely to mess up. Now the bit will stick, you'll damage the threads, or if you're pressing across it with a rounded tip, then the thing's not going to go in straight and the angle's going to be all wrong when you try and put the screws in. And I thought, well, there's got to be an easier way. You're going to put a screw in, why not use a screw? You can hold that straight separately, and you can use it as a heat transfer into the insert from the soldering iron bit, and it appears to work perfectly. I've just done those using, well, I used a 2.5mm screw to do the 2.5mm ones, and rather than a 3mm screw, I've got a bit of 3mm threaded rod, so I use that as a guide, which makes it very easy to hold straight. You just heat the side of it up and it goes in, which as I'll demonstrate. Now the 2.5mm ones, I haven't got a threaded rod for those, so I'm going to have to balance those under the screwdriver to do it. Now I must admit I did these with it braced lightly in a vise, but I can't get a position sensible for the camera and lighting with my limited setup for that. So I'm going to try and do it here like this, which I don't know if it's going to work quite as well because this is going to keep trying to turn over. In fact, it's definitely not going to work like that. Let me just rearrange things. I need something taller to brace it against, which I happen to have here. These batteries. Hopefully that will be big enough so it can't escape or turn over. Right. Oh, that's a bit better. I think that'll work. So, famous last words. Just drop one. Okay. Well, that's the idea. In fact, this is purely down to me trying to hold it for the camera. It's not a fundamental problem with the system. If you hold it in the vise or get somebody to hold it for you, then you shouldn't have a problem. But doing this on the Aero course live video, it's all going to go pear-shaped. See if that one might work. It's just that this thing's so rounded and it's awkward to hold, and it's only trapped under light. Anyway, I'll see if I can get it to work like this. So basically, just heat the side of the bolt just above where it goes into the insert and make sure everything's straight and square as it happens, and then that will slowly heat up and melt its way in. I don't know if you can see on the camera that, but it's steadily moving now. The iron's at about 367, I think, at the moment. because it's heating through a piece of iron, the bolt, steel. Actually, I don't know if this hole's drilled out properly. This one was a failure. I didn't set the clearances right for the support, and I couldn't remove the support properly, which is why it looks very, very messy. And this hole might not actually be empty. It's going in. No, oh, it's in. All right, that's it. Right, so put the iron back in its stand. I'll grab that. Now see that insert is in, and whilst it's still warm, you can just move it slightly to ensure that it is square to the item, and steady it whilst it cools down, which you can't obviously do with a hot bit sticking in it. You've got to rely on it staying where you put it not moving. So this gives an advantage that you can steady it, and once that's fully cooled enough to be stable, it won't wobble, you can take the screw out and reuse it. And it's got some little bits of solder splash on it, but oops, I dropped that as well. They're not actually adhering, they're just stuck on the plating because I didn't use any flux, obviously. I'm not trying to solder anything. So that's gone in nicely to that. It's just below flush and it's square. So if we can do one of the 3mm as well, and so that's, I'll be using this threaded rod. Technique's exactly the same, except it's easier to hold because you don't have to try and balance things. If I can get it to some angle, then that one will go, I think. Well, I think, can't help, I'm on a very, very slippery surface. This is a mat, and it's a cutting mat, it's very low friction, and this thing is a very odd shape. So I'm going to work like that to brace it right. I'm going to put a bit of sideways pressure on the thing to hold it at the right angle as well. You see, I've got the iron on just above the brass, so it's not quite touching it, but the heat's being transferred through the metal rod, or the threaded rod. And because this is iron or steel or whatever, the heat conduction is not that great, so it's not trying to burn the fingers. I can't actually feel any heat coming through it at all at the minute. So it's very easy to hold it steady and keep pressure on it. That's about halfway sunk now. It takes time for the heat to penetrate everywhere and for the plastic to melt, but it's going quite nicely and it's very controllable. That's getting a near flush. I want it just below flush, and that's about it. So again, that's looking reasonably square. There's a little bit of wobble in the thread. You can see that's set reasonably well. So yeah, again, now that will unscrew and it can be reused. So they have another nice lead set brass thread. Anyway, it's only a short one, but I hope that's interesting and might save some hassle and cost. I think the spare screw that you've probably already got is a lot cheaper than spending £10 or so, whatever these brass adapters cost, even if you get one that fits whatever soldering iron you've got. I'm pretty sure I can't get one for that for my Antex. Anyway, okay, that's it. Thanks for watching, and please hit a like if you enjoyed it. Please subscribe.